kind of crazily ambitious dream, but the trick is, how do you break it down into manageable, achievable interim steps that are meaningful and useful in their own right? And so virtual cell, which is what I call the project of modeling a cell, I've had this idea, of wanting to do that for maybe more like 25 years. And I used to talk with Paul Nurse, who is a bit of a mentor of mine in biology. He runs founded the Crick Institute and won the Nobel Prize in 2001. We've been talking about it since before the in the 90s, and I used to come back to every 5 years. It's like, what would you need to model the full internals of a cell so that you could do experiments on the virtual cell, and what those experiments in silico, and those predictions would be useful for you to save you a lot of time in the wet lab, right? That would be the dream. Maybe you could 100x speed up experiments by doing most of it in silico, the search in silico, and then you do the validation step in the wet lab. That's the dream. And so, but maybe now, finally, so I was trying to build these components, AlphaFold being one, that would allow you eventually to model the full interaction, a full simulation of a cell. And I'd probably start with a yeast cell, and partly that's what Paul Nurse studied, because the yeast cell is like a full organism that's a single cell, right? So it's the kind of simplest single cell organism. And so it's not just a cell, it's a full organism. And yeast is very well understood, and so that would be a good candidate for a kind of full simulated model. Now, AlphaFold is the solution to the kind of static picture of what does a protein look, 3D structure of protein look like, a static picture of it. But we know that biology, all the interesting things happen with the dynamics, the interactions, and that's what AlphaFold 3 is the first step towards, is modeling those interactions. So